Okay, so let's start doing question number 5. For question 5, they show you the graphs of some sine and cosine functions, and then they ask you to find the function. There's a couple of important things that you need to remember before doing this question. Number 1, the graph of the sine function. So let's say we have y equals sine of x. The graph is going to be like this. So from 1 to -1, up, down, up. Period is 2 pi. Starts from 0.00, goes to pi over 2, pi, 3 pi over 2. The most unique thing about, and it keeps going, the unique thing about sine starts at the origin and goes the opposite way on the negative side of the equation, of the graph. And then we need to remember the graph for cosine of x, so y equals to cosine of x. It's very similar to the sine function, but instead it starts at 1. It doesn't start from the origin, starts at 1, but still has the same amplitude of 1, just like sine of x. So we go over here, we have pi over 2, pi, 3 pi over 2, and then the period is also 2 pi. Okay, these are the two most important things that you need to remember. And the third most important thing is the formula for the phase shift, the period, and the amplitude. The formula is y equals to a sine of bx plus c plus d. So the d is the vertical shift, c is the phase shift when we move the whole thing like to the right or to the left. B helps us find the period using the formula period equals 2 pi over b, and then A is simply the amplitude. Okay, these are the most basic information that you need to know. So let's use that information to solve question number 5. For some reason question 5 didn't really print good, so I had to kind of stimulate the graph using my hand. Okay, let's start with part A. By looking at this graph, we see that it starts at 1, but it doesn't exactly go down as the cosine function. We also see that it has the same period as sine of x, and it never goes over the x-axis. It also goes, the amplitude goes up to 1 and goes up to 0.2 and then goes down to 0. So a is still equal to 1. Using this formula, a is still equal to 1. P is still 2 pi. The period is still 2 pi. So the b is still a constant 1. There is no phase shift, and the only difference is that it goes above the x-axis by 1 between this and the sine of x graph. So all we gotta do is just add a vertical shift of 1 to sine of x to get this graph, and then we get sine of x plus 1. I know it might be a bit confusing, but you need to do a lot of practice to be able to see how we can come up with this, or how do we actually see this. Okay, question number 2. We can see that it starts at the origin but doesn't start at 0.00. It goes through the x-axis and it has an amplitude of 2, but still has a period of 2 pi. So we can test this. It has an amplitude of 2, so a equals 2. By the way, this is a generic equation for sine and cosine. The period is still 2 pi, so it didn't change, so it's just x. There is no phase shift because doesn't move when compared to the cosine of x graph, and there is no vertical shift because it's still in the exact same location as cosine of x but with a different amplitude. So the only difference between this and cosine of x is the fact that a equals 2, so the answer for this is just going to be y equals to 2 cosine of x. Hope this is making sense. Okay, for part C. Okay, part C gets a bit more complicated. So first we can see that this graph goes through the origin, so we're going to compare it to the sine of x graph. It has the same amplitude because it goes through the point 1 and negative 1, so a still equals 1. But we can see that it has a different phase because it ends at 2 pi over 3 and it has a much higher frequency. So p, we know that p equals to 2 pi over 3. That's a very important thing to know. There is no phase shift by just looking at the graph, and there is no vertical shift because it still acts as sine of x but with a much higher frequency and much higher period. I think I said phase shift by mistake at the beginning. It's the period that's different because we have much higher frequency. So how do we find the value b that makes us have the period of 2 pi over 3? Okay, to do that, we know that p equals 2 pi over 3. And we know that to find p, we use the formula 2 pi over b. So we know that 2 pi over b equals to p, and we know that p equals to 2 pi over 3. So we can just do this. 2 pi over b equals to 2 pi over 3. And then we just solve for b. So dividing by 2 pi over 3 on both sides and multiplying by b, we have b equals to 2 pi over 2 pi over 3. 2 pi's cancel out, and then b would just equal to 3. So we know that b equals to 3, and that's the only difference between this graph and the sine of, we know that b equals 3, and this is the only difference between this graph and the graph of sine of x. So the formula for part C is just y equals to sine of 3x. It's pretty easy so far. Okay. Part D. Let me just take a look at it. Okay, so for part D, there's a couple of things that are a bit different. So first, we notice that the amplitude went from 1 to 1/2. So A equals to 1/2 because it goes to 1/2 and then goes back down to negative 1/2 and so on. Keeps oscillating at that rate. We also notice that the period now is pi instead of 2 pi. So it was kind of cut in half. So there's two things that we need to change. The fact that a equals to 1/2 and that the period equals to pi when compared to the graph of sine of x, because this one goes through the origin, that's why I chose sine of x. Okay, so first let's find the value b in sine of b of x. We know that 2 pi over b equals to p, and we know that p equals to pi, so we can just remove this and make this pi. Divide by pi on both sides and multiply by b, we will have b equals to 2. So now we know that this value b is just 2. And now we can just plug in. So we know that a is 1/2, b is 2, so the answer is just 1/2 sine of 2x. Because there's no vertical shift and there is no phase shift. There is only a different period and different amplitude. Okay. Okay, the last question might be a bit confusing because there's two things that changed. Okay, the first thing that changed is that the period has no pi's in it. It absolutely has no pi's. The period in this question was just the number 2, so p equals to 2. And the second confusing thing is that this graph doesn't exactly look like the graph of sine x. The graph sine of x goes up, this graph goes down. So the main difference is that this graph basically just has a negative sign in front of it, which caused it to flip. So we can say that this is the amplitude is, the a is just negative, or we can just plug in a negative sign at the beginning. So we have negative sign of something times x. We call this something b. So now we're trying to find b. Let's do that real quick. We know that p equals 2, and we're trying to find the value p. We're trying to find the value b. We know that 2 pi over b equals to p, and we know that p equals 2, so we can just make this become a 2. Divide by 2 on both sides and multiply by b, we'll have b equals to pi. So now we know that b equals to pi, and that there's a negative sign in front of sine of x, so the answer would simply be y equals to negative sine of x, sine of pi of x, because b is pi. I know that this topic might be confusing, but I recommend watching the organic chemistry tutor's video on this. It's very helpful, and he has a lot of examples that can help you understand this much more. Okay, I'll see you in the next question.